What happens when you take a $1 million traffic generator and fire it at a $279 super popular router and firewall device? That's exactly what we're gonna find out today, so let's get to it. Hey guys, this is Patrick from STH, and this is the Ubiquiti UCG-Fiber, or the Cloud Gateway Fiber. Now this is a small desktop router, but it actually is pretty darn high performance, and I think a lot of folks really like it for all that it can do, and I totally get it. But at the same time, there are a bunch of reviews on this, but I couldn't find some simple information, so I decided, okay, well, we're gonna go buy like 5 of these units, so that way we can actually go do a proper review of this unit. And what do I mean by that? Well, let me give you some examples. First off, I couldn't find internal photos of what the board looks like, so we had one that I don't think is ever gonna work again, but we've actually taken it apart so you can see that. And then another thing is, most of the testing, in terms of performance testing on this, even on the 10 gig ports and 2.5 gig ports, it's all using iPerf 3 mostly. And frankly, guys, I get it. We've been using iPerf 3 for years. Well, we've had to use iPerf 3 because that's the inexpensive free tool that I think everybody uses. The challenge with iPerf 3, of course, is the fact that it's completely useless traffic for something like a firewall like this. We've heard the thoughts that you guys have had on some of our previous reviews, and we've done something, I think, kind of exciting. And that's because we took a $1 million load generation setup and we fired it at this little $279 device. You could say that that's not fair, and that's probably true, but we not only managed to go and run a lot of traffic through this, we even managed to get this thing to just give up and say, yep, I'm done, requiring a hard reboot, power off reboot, to be able to get it to start passing traffic again. And guys, we're gonna show you all around this because I do think that this thing is a really good router box. After we've tested it for a little while, there are definitely some limitations, but when you see what those limitations are, I think you're gonna be like, okay, I get it, and it's cool. Okay guys, I just wanna get this out of the way real quick. These units were not furnished by Ubiquiti. We're actually using our STH YouTube membership revenue, so if you wanna join down below, that would be super awesome so we can keep buying these units. But the reason that we had to buy them instead of getting them furnished is because, well, we refused to sign the Ubiquiti agreement. That means that they can go and like look at stuff beforehand and get previews and all that kind of stuff. Like, we're doing this editorially independently. So I just want to point out that it is a little bit different. It's also why we're able to go do things like, you know, open up the system and show it to you. With that, let's get to the hardware. Okay, and so let's start off with what do you even get with this? Now, this unit here has a nice little LCD screen in the front, and it gives you basic information. It's always just nice to have. But then the other thing that I think is important is really the ports on the back. So we have our power input over here. It uses a 54 volt DC input, which is, you know, pretty common for like PoE devices, but it's a little less common on some of the other just kind of mainstream systems. And on the rear panel, you're gonna see that we have 2 SFP Plus ports, as well as an RJ45 10 gigabit Ethernet port. Now, these 2 ports over here, both the SFP Plus and the RJ45, they are 10 gigabit Ethernet, but they're also WAN ports, or at least configured as WAN ports out of the box. And we also have these 4 2.5 gig Ethernet ports. One of those over here is a PoE port, so that way you can go and power your APs. That's actually why we have these Ubiquiti Wi-Fi APs here, because this one, for example, is a U7 Pro Max, and I think that's the U7 Pro. And these are devices that you can actually plug directly into this and get pretty darn good Wi-Fi coverage because you have a PoE out. I love that. One thing I do wish, let's call it what it is, I wish that all of the ports were PoE, just because I feel like on a Ubiquiti device, it would just be awesome if you could plug in a couple of these, because like, it's cool to plug in 1, but if we could plug in 2 or 3 or 4, that would be a lot more useful in a little device like this. And hey guys, something else I just thought is interesting in this is that, let me just show you this. This is a Fluke Networks microscanner PoE, and what you'll see is that our tester is actually showing that we get about 25.5 watts PoE, so we know we have a PoE plus port on this Asus EDG19P gigabit router that we've looked at previously. Now, one of the weird things about this Ubiquiti is that we get something different on its PoE port. So let me just show you what that looks like. But you're gonna see that as this is searching and trying to find and negotiate that PoE standard, we're only getting a 6.5 watt here. It's a class 2. This is a crazy thing that we've seen in a couple of other switches, especially using this device. Now, this is of course a pretty well-known scanner in the industry, or tester in the industry for PoE. If you have things that are a little bit out of spec, it will oftentimes give you some kind of wonky result. And so that's why, like on some of the Hasbro switches and other things that we see from AliExpress, we get weird results kind of like this one. But I just want to point out, this is something that I haven't seen anybody else talk about, but if you do use a higher end PoE scanner device, it's kind of auto negotiating down to a lower level of PoE, which is not ideal. And it's weird that we haven't seen it anywhere else, especially given how many folks have reviewed this so far. We did manage to test this on 3 of them, and we got these same exact results. So I don't necessarily know if it's a fluke with the units, but since we have 3 of them, I don't think it is. I don't think it's a fluke with the meter because we have 2 of these. I think it might just be a weird negotiation thing. Now, one other feature, if you were actually to go and purchase this, is you're gonna see that right here, there's a little spot, and I'll just kind of show this to you real quick. You might be wondering, what in the heck could that be? Let me show you the configuration page real quick, because you have options to either do a bare bones no storage unit, which this one actually was, because we bought a lot of these, of course. But then you also have a 1 terabyte, which goes up from $279 to $399, and then a 2 terabyte model, which goes up to $529. And guys, let's just be clear. 2 terabytes for $250 is like, it's crazy amounts of money, right? So one thing I wanted to show you though is we did get the 1 terabyte model just to show you this. And just to be fair, Ubiquiti has a little kit that's like $19 for the little add-on. So you can use your own M.2, but we're using the Ubiquiti one here. And I just want to show you how this works. So you go to this little port right here, you push it in, boom, and then you take your drive and you place it in here. And that's it. Now this thing has 1 terabyte of storage that we can use for something like if we need to record things or whatever we want on here. Now we have 1 terabyte of storage. It's solid state storage, so it's pretty reliable and we don't have to worry about it. And again, this is all in a little tiny chassis that fits in my hands. I absolutely love this, guys. With that, I know you guys want to see what's inside of here. And Sam, who's operating the camera right now, he is absolutely laughing his keister off right now because he had to go, and I told him, I said, hey Sam, why don't you go open this up? And let me just tell you, he showed me, and this is not easy to open by any means. I think he thought this was a total pain in the posterior. And so let me just kind of show you what this looks like. Okay, now there's probably a better way to get in here than what Sam and I did. This thing is actually designed a little better than I thought. This is actually a little heatsink thing over here. And you can see their theory on how they do this. And I'll just say that they do a pretty good design. I was pretty surprised when I saw how well this little box and inexpensive box was actually designed. Now, let's go talk a little bit about the actual PCB, which I don't think a lot of folks have seen. By the way, you might be wondering why this fan is here. The fan is actually glued on, and I think we originally thought that we were gonna reuse this, and then we realized we were not gonna be reusing this. And the reason that finding an internal fan that's glued on and that's hard to get to is such a big finding is because over years, these things will collect dust and grime and whatever. That can, of course, lead to a fan failure. But another challenge is that if you just wanted to clean this because it was starting to get noisy because it's having to run faster because of the dust and grime or whatever stuck in there, well, it's hard to do that because it's hard to get into this chassis. We had to destroy ours. And the other thing is that even if you did, you can't even really replace this because it's glued on. So it's not really a user serviceable part, even though it's a fan. And I don't like to see that in any system that we review. And we're just gonna show you some shots of this board just so you can see the top of it. One thing that was kind of interesting is that there's this like thermal pad that we had to pull off on this side. And the reason for that is actually that on the other side, we have the main Qualcomm chip. And just in case you're wondering about the processor, this is a ARM Cortex A73 quad-core processor, and it's only running about 2.2 gigahertz. Not the fastest thing in the world, but not too bad. We also, of course, get 3 gigabytes of memory here, so it's definitely not something that you can run giant systems with because it's only 3 gigabytes. That's done, of course, and I know a lot of folks are like, oh, I don't use anything smaller than 4 gig SODIMMs. Well, just remember here, guys, this is an embedded system, and this is also meant for low cost operation and manufacturing, so that's why you only get 3 gigabytes. And by the way, guys, after we took this apart, I think we figured out why. We watched a whole bunch of videos and looked at a whole bunch of reviews, and we couldn't find anybody who had done it because honestly, I don't have a high degree of confidence that we would get this back together working, which is why we have more than one. So we took it apart so you can see what's inside, but I wouldn't necessarily recommend that you do this yourself. Okay guys, so let's talk a little bit about the power consumption of this device. At idle right now, we're getting about 8 to 9 watts, so it's a super low idle power consumption on the box. Now, the Ubiquiti folks say the max power consumption, excluding the PoE output, is about 29.4 watts, but there's also a 30 watt PoE budget. And we get this nice little power adapter over here, which is 59.4 watts, which gives us 30 plus our 29.4 watts. So it's nice how that works out, huh? And guys, you probably remember that we saw that there was a fan inside. Frankly, we now have had 5 of them. One of them is no longer surviving. but you really don't hear the fan that much, if at all. We've run a lot of traffic through this, and this thing's not really that audible. So I wouldn't say it's a totally silent device, but like we're talking, usually if we're about a meter away, we're talking like in a 34 dBA noise floor studio, we're usually talking like 35, 36 when this thing ramps, maybe 37, but like well under 40 dBA. So I really wouldn't be too worried about the noise. I actually like the fact that they added a fan because that's probably better for longer term reliability. Now, this is a little system and it's about $279, but at the same time, we said, hey, what if we actually do some real live network traffic on this thing? Like, what the heck will happen? It claims to be a 10 gig device, so like, what would we see? And so for this, we have something brand new on the STH main site, and that is our new Keysight CyPerf load generation tool. Now this Supermicro server is running the software, and just to give you an idea of what we have here, we have four 400 gigabit per second NICs. We have a 4x50 gigabit per second NIC. We also have 4x10 and I think 2x10. And so we have a bunch of NICs that are in here. We went and have spent months getting this set up. And let me just talk about some of the challenges that we've encountered doing this project, right? First off is the cost. This is ridiculously expensive because it's not just the cost of the box, which by the way, this has the highest end Intel Xeon processors that you can get right now. We have the high-end NVIDIA NICs. We've even had to get things like custom cables made to be able to do the right NUMA node balance to the different NICs and get the traffic to go to the right NUMA node in the right place and all that kind of stuff and make sure that that's all tuned. But beyond that, we also need a way to be able to get down to 10 gigabit per second SFP, which seems easy, but what you don't want to do is run like a 10 gigabit per second port and only have 10 gigabits per second of total bandwidth coming out of the box and trying to test a device that's 10 gigabits per second. But even that is harder than you would think because we are using OSFP NICs here, and we have to go OSFP to a lot of times QSFP-DD or QSFP56DD to be able to even get down to other 400 gig devices. And guys, it's just a nightmare. We have literally tens of thousands of dollars of optics. This NVIDIA switch right here for our higher end testing that we're gonna be doing on the STH main site, this NVIDIA switch is something like $65,000. We have a number of other switches that we just didn't bring on set, but to be able to manage going from higher speed to lower speed and also doing some of the media conversion. And we had to go get optics and what have you that have gearboxes, and it's just, honestly guys, this has been a bear to just physically get set up. We've already tested this to well over 1.6 terabits per second of total throughput. And that's not just simple, here's one packet size, giant packets, all that kind of stuff. Absolutely not. What CyPerf does, which is very different than like an iPerf 3 that just kind of sends pretty uniform packets and it's just kind of really easy traffic, is that CyPerf can generate real world workloads. It's not really designed, frankly, for something like a $279 box. But on the other hand, we saw something so cool when we actually launched it. This was a screenshot we took when we were running some traffic from one of our many workloads that we're going to be running on these devices. And what you'll see here is that we have all kinds of different things. We have Twitch traffic, Facebook traffic, eBay, Gmail, all kinds of different applications running. And not only does the Ubiquiti device see these as flows for these different applications, but also we're doing this across a number of different countries and geographies. Why that matters is that the CyPerf tool is also able to inject attacks. Now we ran the attack flows on this thing, and frankly, I think we ran like something like a couple hundred attacks on it, and this stopped like 5 in its default configuration, but there is an option to go and get a license for the, I guess, higher end threat protection. Let us know if that's something that you'd want to see in future videos, because it's definitely something that we'll go do if there's an appetite for it. And just to give you an idea of what that looks like, I posted this on X a little while ago while we were setting this up and just trying this with various different systems. And something we saw was like, we did over 5,000 attacks, and this thing out of the box stopped like 70 of them, which, if you think about it, it's actually a really important metric though, because you think about how many people will just go buy a box like this, plug it in, they get their network working, and they're like, all right, well, hey, I'm good. I don't really need to go do something else. But we can actually generate attacks, like real world attacks, and generate them as part of an overall application flow. So it's not like every single packet coming across is a different attack. It's like, embedded in hundreds of different flows and, thousands of users. And while we were setting this up, this thing did absolutely awesome. Like, for example, this is a 500 person all hands Zoom call where we set up 5 folks as presenters, and then we set up another 490 folks as attendees and generated the traffic through the router like this. And you'll see that we saw absolutely no issues. So folks folks were sitting on this call and they're like, hey, I can hear it just fine. The video streams are coming in just fine. This thing is absolutely fast enough to do that so long as your WAN and LAN connections are fast enough. And not only do we get these awesome quality metrics, we can even jump down into like the jitter that we see on the device. And just to test out something that we thought was fun, Ubiquiti says that this is good for like 500 users, but we said like, well, okay, but what if we generated a lot of traffic and we generated across a lot more users? So we went to about 1,500 users and over 60,000 concurrent connections. And by the way, you can see over here just some of the applications that we were running. We were trying to simulate like a giant office running all kinds of different applications from like Amazon, like just buying stuff, to Amazon Prime Video, CNBC, Gmail, and Google Drive, and all that kind of stuff. We had a ton of different applications running here, and that's one of the reasons that you see that this kind of gets a little bit spiky, because we're trying to maintain a application mix, and depending on like how those applications run, you actually kind of get this thing. So it's not like iPerf 3 where it's just roofline. It's actually showing, here's if you're trying to run all these different sessions and users, what it looks like, because you can see it's actually ramping up the number of users doing this. And that's the reason, guys. And by the way, we ran this at full 10 gigabit full duplex, so just around 20 gigabits per second, which you can see here. And by the way, for all intents and purposes, this is a 10 gigabit bidirectional link, because you have to remember that depending on where you're measuring your gigabits per second, like what layer in the stack you're measuring that at, it's gonna be a little bit different. So we 100% would call this a full duplex 10 gigabit per second link, because we're able to push 20 gigabits per second through here. And of course, that was interesting at 1,500 things, but the way we figured out that 1,500 number was we actually let this thing go all the way up to 2,000 users. And just as it passed like 2048 users or somewhere around there, we saw this happen. Now, in case you're wondering what this is, you're seeing that we're getting, pretty close to 10 gigabit per second traffic. And if you look over here, you can see our concurrent connections are going up as our users are scaling, as our traffic is scaling, and then all of a sudden you see it just drops like crazy. And what's happening here is we are actually getting to 2048 users, and the second that we hit 2048 users, and we're at 46,000 concurrent connections, we can actually get to more concurrent connections. We showed that on the last one. But on this one, when we got to 2048 users, all of a sudden, the traffic just shut off. And the reason this was absolutely fascinating, even though it's a much larger deployment than you would expect this to run, right? The reason it's fascinating is the failure mode. What happened with this router is that the application actually, we hit this limit, traffic shut off. And when I say traffic shut off, like literally it just stopped passing packets. Like it was done, I'm done, like I'm not doing anything else. We had to physically go and power cycle the unit to get it back online. And that's important for a lot of folks because they want to know how these types of devices fail. And so I just wanted to show that off and just let you know. Now, of course, if you have a 2,000 user environment, this is the wrong device. You should be going to a better one, right? That's a little more expensive than $279. That's life. One other crazy note is that while we were running what is going to become a standard profile with an 11 app mix, we also saw this unit just stop passing traffic. This was only at 1536 users, so it's much lower than that 2048. Typically what that means is that we're running into an issue either with the buffers or just the amount of system memory or something like that. And that typically is what you'll see causes this type of just, systems just stop. But again, 1536 users is more than you would expect in a gateway device like this. I do want to point out though that we don't have other things turned on. Like we don't have UniFi Protect, for example, turned on, or any of the other features that you can add. We also are not doing the full IDS stack. We're not doing any of the fancy firewall things that you can do. This is pretty much just a vanilla application stack. And so the fact that we are able to go and create these failure modes is something that I haven't seen anybody else talk about, but I do want to just point out that it does mean that the gateway will just stop passing traffic, and some folks may have an issue with that being the failure mode. And guys, one of the big reasons that you use something like this is because Ubiquiti has an awesome integrated software suite. So you can do things like if you have their security cameras, you can run the NVR function on here and use this 1 terabyte SSD and start recording security cameras as an example, and it's easy to set up in the UI. This also runs as a controller, so you can have multiple Wi-Fi APs, and instead of having to have a virtual machine or something in the cloud or something like that running the Ubiquiti controller, you can just do it on this little device, and it's pretty inexpensive. So to me, this thing is so easy to use that I just love it, especially if you're gonna get invested into the Ubiquiti ecosystem. Now, if you don't want to be in the Ubiquiti ecosystem, then I don't necessarily know if this is the right device for everybody, But I will say that even if you have like a totally, MikroTik switch ecosystem and, other folks for APs and whatever, you can still use this as a gateway and a router device. So just kind of keeping that in mind, that you can just deploy this and then use a couple of the Ubiquiti services as you want. And that's the deployment scenario. But on the other hand, the UI is absolutely great. Now, with all of these videos, I love to have key lessons learned. What do we learn from this whole setup and this whole experience, right? I think there are a number of things. The first thing that I learned was, frankly, I really like this package. I think this is overall an absolutely great package. I don't want to let you guys like see that failure mode and think like, oh, he thinks this sucks. Absolutely not. I think for the vast majority of folks, this is especially homes, small, medium businesses, all that, I think this is absolutely great. We mentioned this earlier, but I don't like not having a user serviceable fan. I think that this should be easy to get to because it will collect dust and it will make the overall gateway noisier. I don't know, we are always like everybody else testing these new, so we don't really have the benefit of that, but that's why I like to see these be user serviceable. But if you take away nothing else, I think a couple things. Like one, what does this look like inside and like how to get in it? We couldn't find anybody that had done it. Maybe some folks have, but we couldn't find it. So, well, now folks will be able to see inside. And of course, as a key lesson learned, I think it's also worth noting that we found a Fluke using our Fluke validating the PoE output, because this clearly we've been able to output more wattage than this, but it is a little bit strange that we only negotiated to PoE rather than PoE plus using the Fluke devices. The other thing though is also just letting you see what this new generation of network testing is on devices like this. I think it's important because there's so many folks that are just testing with iPerf 3, and it makes sense because that's like a very low cost thing. I mean, frankly, even just the hardware that we have, this is a six-figure just hardware project, not including the software licenses to even run something like this. But as you saw, as we scale the number of users, concurrent sessions, also the types of traffic, we don't necessarily hit that 10 gigabit per second roofline performance, and sometimes we don't even stay close to that. And it's not because our $1 million load generation device can't generate traffic, because we've tested this up to over 1.6 terabits per second. Instead, this is because, well, that's just a pretty low performance ARM processor that's in here, and that's really the point of a low power, low cost device like this. So something you definitely will see is that we'll have more reviews, especially on the STH main site, because it's going to take a lot to go into a lot of this data and give you real insights out of it, just because we're generating so many data points these days. But on the other hand, I think as we do more network device review testing, we're going to be using this a lot more. And so as we use this, I think you're going to see that on the STH YouTube channel as well. Again, that's why I want to know what you guys think. And by the way, guys, we're only showing the high-level details of that CyPerf tool. There's tons of data points. We get like PDFs with over 50 pages in them. If you do want to see that extra level of detail, let me know down in the comments. We have to figure out how to actually get that much data to folks, because it's just a ton of underlying data that goes into making these. And since we've only used our $1 million tool that's taken like 4 or 5 months to set up and get to this point by now, for one review, I guess, this might be the most expensive video that we've ever done by a pretty wide margin, but I'd love to hear what you guys think. And also, hey, if you like this video, or you just think somebody would benefit from seeing what higher end testing on a device like this would look like, why don't you share it with your friends and colleagues? But also give it a like, click subscribe, and turn on those notifications so you can see whenever we come out with great new videos. As always, thanks for watching and have an awesome day.